Thank you, John. I don't really know how to introduce my next guest. So I'm just going to tell a little story. About maybe a year and a half ago, I realized my career had reached its peak when I was in a meeting with the DHS CIO at the time, my CTO, and Vint, and we were whiteboarding. And I thought, what better a career peak to whiteboard with a man of Vint Cerf's stature? So Vint, as you know, was one of the, we call him one of the godfathers of the Internet. I think he doesn't really like that title, but I do. So I'm going to shamelessly use it. He is here to talk today about NEEM, I believe, in cloud computing. I don't believe we need too much more of an introduction, but please, a hand for Vint Cerf.
Good morning. First of all, we have to convince this Okay. Can we get this up on the screen here? We've got a bunch of CIOs in the room. They ought to be able to figure this out. Let's try that. Thank you. Well, theoretically, this other microphone should work too, is it not? My God, you want me to clip this to my left nostril? I asked it to detect displays. Oh, I see. It has to go to 1024. Okay, so you have a wimpy projector. Let's try that. It still doesn't want to. Well, that's interesting. Try that. And amazing. Let there be light. Well, first of all, happy fiscal New Year's Eve. It's the end of the fiscal year. And second, I have to tell you, I got very nervous when I heard that you were planning to break out and throw up slides. And then I heard about the H1N1 stuff, and I'm worried about whether I should stay here or move on to some other safe location. Let me start by warning you that I'm not going to get into a lot of detail about NEEM because you're going to get lots and lots of that during the course of this session. But it's very important that you're all here. For one thing, there are a lot of you, and the implication of that is that you care about this topic. And the side effect of that is that we have a shot at actually getting a lot of the federal government's information into a form that's interworkable, interoperable, processable, and the like. So I want to focus a little more on the framework in which NEEM may find itself integrated, and that's with regard to Internet and cloud computing. So let me start out by just taking you way back into history and show you a picture of the original ARPANET, which was the predecessor to the Internet. It was the first experiment in packet switching, wide area packet switching. It was a 4-node system. The first node was installed on September 2nd, 1969. I was a graduate student at UCLA, and I wrote the software to connect the Sigma 7 machine to the first interface message processor of the ARPANET. And the Sigma is in a museum now, and some people think I should be there along with it. But I'm not. And if you fast forward to 99, this is what the Internet looked like. And of course, if you look at the 2009 version, it's the same. It's just bigger and more colorful and more connected. The scale of the system is pretty significant now, almost 700 million machines on the network, and those are just the servers. That doesn't count the laptops and PDAs and things that are episodically connected. On getting towards 1.7 billion users on the network. That's still only about 23% of the world's population or so. So we still the chief internet evangelist at Google has 75% of the world's population to convert. So I have plenty of work ahead of me. What is very important, though, about this internet environment is at the bottom of the screen there. It's the 4 billion mobiles that are in use today, and that number continues to grow. That doesn't necessarily represent 4 billion people, because some people have more than one. On the other hand, some mobiles are shared. You get out to some villages and you find the mobile lady who will actually sell access to the mobile for a small amount of money. So the numbers are impressive. What's important is that many of those are Internet enabled, and so for companies like Google, figuring out how to present products and services through a fairly limited interface, possibly low data rate, very small displays, and so on, is actually quite a big challenge. And for many of you, to the extent that your work touches on the end users, mobile access may turn out to be a very important aspect of what's going on in the healthcare world. In particular, I can imagine having your mobile remind you that it's time to take a pill, or a mobile which is picking up a Bluetooth signal which is keeping track of various vital functions, vital signs. So mobiles are becoming an increasingly important part of our world because they're not just telephones. They're programmable devices, and they're becoming a part of the communications and computing environment. This year and next, there are a lot of changes happening to the Internet, probably the most significant changes that it has experienced since it was rolled out in 1983. One thing is an expanded Internet address space, IP version 6, which allows for 3.4 times 10 to the 38th addresses, which I'm happy to say is bigger than your budget at HHS. I don't know what you're shooting for, but, you know, if we need 128 bits, you know, for the budget, we're in real trouble. Another very important thing that's underway right now, we're in last call for the revised standards for internationalized domain names, which means domain names that are written in characters other than Latin characters, so, you know, Cyrillic and Hebrew and Arabic and so on, Chinese and Korean. It's actually turned out to be harder than it looks to actually get that to integrate with the original design, which was very simple, A through Z, 0 through 9, and a hyphen. I was the chair of the working group that produced the revised documents, and they are in IETF last call, literally as of today. Another thing which is everyone is worried about is security on the Internet. So the domain name system is vulnerable. There is a design and implementation underway to digitally sign all the entries in the domain name system. It's something that each name server operator decides for himself. The root zone file should be signed by the end of the year or early next year to begin with, and then that whole thing can propagate down. But some top-level domains are already digitally signing their zone files, like Sweden and Bulgaria, of all places, and others, Puerto Rico, and so on. There's another issue in the routing system of the Internet. It's possible to falsify announcements that say, hi, I'm an autonomous system and I have responsibility for this address space, even if you don't. And people are beginning to hijack IP version 4 address space because we're running out of it. We're going to exhaust that address space somewhere around 2011. So some people are beginning to simply announce that they own pieces of the address space, and that gets injected into the routing system. In order to combat that problem, the regional Internet registries that are allocating IP address spaces are building tables in which they can digitally assert that a particular autonomous system has been assigned a particular block of IP address space. And when you get a routing update, you can verify whether or not the AS that's announcing that routing update is, in fact, has the authority to do so. And if it doesn't, that goes away and signals go off and somebody goes to try to track down whoever is hijacking the address space. Another thing which is clearly beginning to show up, and I'll give you at least one example, is sensor networks are beginning to be part of the Internet environment. Intelligent devices that gather data and exchange it or send it for aggregation and evaluation. In the healthcare world, that's certainly a growing thing. And, of course, the smart grid, which is underway now, at least being in concept, is another place where a great deal of sensor and control information will be flowing around in the system. And I've already mentioned mobiles. At Google, we care a lot about the application space and the Internet, and I'm just going to flip through a bunch of applications as a reminder of how broad the scope of things is that we do on the Internet. It wasn't designed to do all these things. In fact, it wasn't designed to do anything in particular. And the fact that it wasn't designed to do anything in particular has led to this cornucopia of things that it can do, which is pretty surprising. So don't specify things too deeply because you want to stay flexible. So there's emails that's been around since 1971. Not Gmail, but the email has. Chat and things like that have been around forever, and now it's not just text, but it's audio and video. Skype is another example of something that you do. This is all with a best efforts network. There's no guarantee of quality of service or anything else. And people run around arguing, oh, we have to tie this thing down and make sure that every bit per second is carefully monitored. And oddly enough, for an awful lot of the Internet, we don't do that, and it works anyway. How about Twitter? In fact, I noticed that you guys have got the NEAM conference following on Twitter. I have trouble with this. I was telling John earlier that I tweet is the verb, and I never remember that, and I always think twit is the verb. And then I got to thinking about what's the past tense of twit, and I stopped there, so we're not going anywhere. A recent experiment at Google is Google Wave. I had a lot of trouble with this concept, but the basic idea is to take one application and make it do all kinds of different communication, make it adapt. So not only would you be doing chatting and interactive things and the equivalent of tweeting, but you would also incorporate people who had blogs and structured conversations and so on. It's all part of a single application. And what happens is that you can use this one Wave application to interact with people who see you from the Twitter point of view, or they see you from the instant messaging point of view, or they see you from the email point of view. This single application aggregates all of that. Now, there are some potential side effects here, and that's why we released this early as a beta thing. If you were accustomed to an ephemeral communication, like a tweet or an instant message, and think that it sort of disappears into the ether, if someone else is interacting with you using email, for example, or a blog, and the tweet shows up on the blog and the blog gets indexed, suddenly an ephemeral communication becomes an archival communication, and that's sometimes a surprise for people. So my guess is that we have a lot to learn about this very clever attempt to aggregate all these different forms of communication into a common interface while at the same time preserving people's expectations. So I don't know how that's all going to turn out. WebEx is another example of a collaborative tool that people use frequently to make presentations and to have conversations about work that they're doing. Google Maps is another example of a kind of collaborative tool. The collaboration in the case of Maps is a sharing of information, which is, of course, at the core of what NEAM is trying to do. It's trying to help people take information and make it shareable and therefore more usable for people. And we found that the interfaces, the APIs that we use at Google Maps have been very popular simply because people can take geographically indexed information and share it in a common framework. Google Earth is another example of the same kind of thing where we've stitched together a lot of imagery, bound it to geographic coordinates, and then other people can make use of that presentation environment. Here's Google Oceans is another example. Here's Google Mars. I don't know whether you have any activities currently underway there, but NASA does. They have 2 rovers and the Phoenix lander, which went out of business about 90 days after it landed, as planned. So Google has stitched together a lot of the NASA imagery, and you can fly around in Google Mars just the same way you can fly around in Google Earth. We have a Google Moon also, and we have Google Sky. So we've taken a lot of the NASA-supplied imagery, especially from the Hubble Space Telescope. You can zoom outward 14.5 billion light years to see some of the early galaxies. So I have to say, kids love this sort of thing. I mean, it's just really exciting to get in your spaceship and take off. This is the kind of thing that allows people to share and aggregate large quantities of information coming from many different sources, which again is a major NEAM objective. Android is an operating system that we released for mobile use. It's free, it's open source, anyone can modify it and make use of it. Google Chrome is another open source browser which we released in order to, we hope anyway, improve the state of affairs of browsers, which are the primary source of infection in the Internet today. You know, you understand how browsers work. They go to a website and they download a file, the home page, and then they interpret it. And it used to be in the past that the home page was fairly safe. All it was text and some imagery and a layout. There wasn't anything else that was particularly hazardous. On the other hand, in the ensuing, several a decade or so,